Welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about bias compensation. So bias compensation, it is a technique used to reduce the change in operating point. So basically it improves the stability of the circuit. So the collector to base bias and voltage divider bias use the negative feedback to do the stabilization. So this negative feedback reduces the amplification of the signal. So it is necessary to use compensation techniques. So the compensation techniques are generally based on the temperature sensitive devices such as diodes, transistors are used which provide the compensating voltages and currents to maintain the operating point constant. So here the diode compensation for instability due to VBE and diode compensation for instability due to IC0 and thermistor compensation and sensor compensation. So these are the types of compensation techniques. First one is the diode compensation. For germanium transistor, the changes in IC naught with temperature contributes more problem than for silicon transistor. On the other hand, in the silicon transistor, the changes in VBE with temperature possess significantly to changes in IC. So in both the cases, the collector current varies. So this affects the stability of the transistor. So thus a diode may be used as a compensation element for variation in VBE or IC naught. So in this case the diode is kept forward biased by the diode source VDD and RD. So if the transistor and diode are same material, the voltage across the diode will have the same temperature coefficient minus 2.5 millivolt per degree Celsius. So diode in emitter circuit. So in this diagram we have taken a transistor circuit. In this RE is connected to diode in reverse biased condition and RD is connected to VDD minus VDD. So the diode is reverse biased here. And thermistor compensation. Consider a self-biased circuit with thermistor RT as compensating element. Thermistor is a negative temperature coefficient device. So and its resistance decreases exponentially with increasing temperature. So in this circuit we have taken R1, R2. In place of R2 the thermistor is connected and RC and RE. So here we can check the transistor. The base current is flow from the VCC through R1 to base. So here we get slope of the curve as dou by dou T of RT. So this is the temperature coefficient of thermistor and the slope is negative. So when current flows from base to emitter, the voltage drop across the IE increases. So this will compensate the changes in IC. So with increase in temperature, RT decreases, hence the voltage drop across it also decreases. So the voltage drop is nothing but the voltage at the base with respect to ground. So hence VBE decreases which reduces IB, base current is reduced. So we know the equation for collector current which depends on IB. So beta into IB plus 1 plus beta into ICB naught. So there is an increase in ICB naught and decrease in IB which keeps the IC almost constant. So our aim is to maintain the stable circuit. So for this collector current should be stable. So by using this thermistor in the circuit, we can maintain the IC almost constant. And sensor compensation. So sensor compensation is uses the positive temperature coefficient. Here the temperature sensitive resistive element rather than diodes or transistor is used. So in this circuit we can see that here the sensor is connected from VCC to base and R1, RC and RE are used. So it actually the resistor, the resistance increases exponentially. So the slope of this curve is dou by dou T of RT. This is the positive slope sensor. Here the resistance is replaced by the sensor element. As the temperature increases, RT increases. So it also reduces the current flowing through it. Hence the current through the R2 decreases, which reduces the voltage drop across it. So the voltage drop R2 is the voltage at the base with respect to ground. Hence VBE decreases, which reduces IB. So let's take the assessment. So from the compensation techniques, it refers to the use of which of the following: diode, capacitor, resistors and transformers. So the answer is option A, diode. And which of the following has a negative temperature coefficient of resistance? Sensistor, diode, thermistor and capacitor. The answer is C, thermistor. Thank you for listening this lecture.